Hello, we're going to do a little algebra review. A lot of good resources at tinyurl.com/MrTOT Algebra 2019. I think if you go to the second link there, and that might change, you'll get this light blue worksheet that looks like kind of like this. And this one's great because you can work these things out, and if the answer that you get doesn't match one of the ones in the possible answer list, you will know that you did something wrong. And it's also a way that you can kind of check if you need to practice doing substitution. Well, let me just talk about that first. The very first question is negative 6x, and this will change. These are random. Every time you go to this site, it'll give you different things. Negative 6x plus 9 equals negative 9. There are four answers there. There's 1, 2, 3, and 4. If you wanted to, you could do negative 6 plus 9 equals negative 9 and just plug in those answers and see which one works. And that would be one way to solve it. And if you were doing a multiple choice test, that might be a good way to do it if you have enough time. It's a very time-consuming method. We'd rather figure out, well, what is that number that when I multiply negative 6 times something and then add 9 to it, I get negative 9. So let's figure that out. So our general strategy, the only difficulty about this problem right here, as far as I'm concerned, is that there's a negative there, and that doesn't really change that much. A lot of these, what I call two-step problems, will take the form of some number times x plus or minus some number equals some other number. And the process is always the same. We always want to get the x by itself equal to something, and that tells us our solution. So our strategy is always to get x alone on one side of the equation. Usually we like to get it on the left side of the equation, but it actually doesn't matter. So the first thing we can do, we've got negative 6 times x. That's if I've just got the two letters, the number and the variable beside each other there, it's a multiplication. And then I've got this addition. So I can either undo this multiplication or I can undo this addition first. And quite frankly, it's easier to undo the addition first, because if you undo the multiplication first, you're going to end up with a fraction, which we'd rather not deal with if we don't have to. So let me just rewrite this so it's a little clearer. Plus 9 equals negative 9. Make sure you got the problem written down right. Writing down the problem wrong is a great way to frustrate yourself. So I want to undo that addition. So I'm going to minus 9 or add negative 9, depending on what you think of. So I'm minusing 9 now. That cancels out to 0. So I'm getting closer to having x alone. So those go to 0. And then negative 9 and negative 9, I like to think of this as adding. I'm adding because I'm adding two negatives. It's going to stay negative. It's going to be a bigger negative. It's going to be negative 18. And those are rules that you might need to go back and review. Because if you can do signed addition really easily, these problems are a lot easier. And then the last step is simply, I got negative 6 and x equals negative 18. I'm going to undo that multiplication by dividing. So I divide both sides by negative 6. Negative 6 divided by itself is 1x, or I could just write x. And over here, a negative divided by negative is going to be a positive, and 18 divided by 6 is 3. And once again, knowing your multiplication facts up to 100, so when you divide, and doing them in reverse just makes things a lot easier. You don't have to know them, but you'd rather not have to drag a calculator out to do 18 divided by 6. So, even if you're 50 years old and you still have problems dividing two numbers less than 100 that are like part of the multiplication tables, you should spend 10 minutes each day for the next week learning those. Okay, so that's 3. And so that was one of my choices. And so when I go back in there, I could actually check myself if I wanted to. Negative 6 times 3 plus 9. So this is the check. And that's equal to negative 9. That was my original problem. And so that's negative 18 plus 9 equals negative 9. And a lot of times when we do the check, we put a little question mark here because we don't actually know if this is going to work out or not. And negative 18 plus 9. Okay, so here's another signed addition. So these are opposite signs. I'm adding them, so I'm going to keep the sign of the bigger one because that's going to win the fight. It's going to pull this over on the other side of the number line. So I subtract the two numbers, but keep the sign of the bigger one. And that's just one of the rules. Okay, so that does check. So that's what a check often looks like. Okay, that was a long time for the first problem. That was almost 5 minutes of me talking. But once again, the basic idea, if I've got something like this, is I'm going to undo this one by either adding or subtracting, and then I'm going to divide by this one. That is, at minimum, if you passed an algebra class, you should know how to do that. So let's do one more. The next one I've got on my list here is 2x minus 8 equals negative 28. Okay, so I'm going to undo, once again, I can say I'm adding negative 8 or I'm minusing 8. I'm going to undo that minus with an add, or adding the opposite, basically. So I got to add over here. So negative 8 and 8 is 0. I'm not going to write that. I'm just going to write 2x. I could put a plus 0 if I wanted to there. And then once again, signed addition. Negative 28 plus 8. They're different signs. So one of the positive or the negative is going to win. The bigger one's going to win. So it's going to stay negative. And then I just subtract the numbers. And so that's 20. And I'm hoping I'm going to have an example here in a minute where they're both the same sign. I'm going to try to find one. I don't see one yet. So let me just, I want to show you one thing. If this had been, oh, yeah, up here, they were both negative. It came out negative. Down here, one was negative and one was positive. If this had been the other way, if this had been like 28 and negative 8, that would have been a positive 20. Because once again, I keep the sign of the bigger one, but then subtract them. And then this is where I land on the number line after these things cancel each other out. So this is where I land on the number line after I cancel each other those others out. Okay, so I got 2x equals negative 20. You can probably do that in your head at this point. We're going to undo this multiplication by dividing by 2. And we get x equals negative 10. And then I could go back and check that. That actually is one of my possible answers on the worksheet, so I'm probably pretty good there. Okay, I'm going to do 2 more examples, and then I'm going to stop. I'm going to do one with a fraction just to show you fractions are not a big deal. Okay, so do not stop watching because suddenly I put a fraction in there. Okay, especially if a fraction is your multiplier. I got 5/6 x minus 7. I can write it well, equals negative 2. Now, on the website, this looks like this. It's 5/6x minus 7 equals negative 2. That 5/6 can be written that way or that thing, but it's not 5 over 6x. It's a little clunky because it's the website. This is the same expression. Okay, first step, undo the minus 7 by adding 7 to both sides. Signed addition, it's different signs. I'm going to subtract the 2 numbers and keep the sign of the bigger one, so that's a positive 5. Oh, there's an example that I wanted. And then I'm left with 5/6 x. Now, that's confusing looking, but the mechanics of doing this is easy. Okay, I can divide by 5/6, and that totally works, except I don't quite know what dividing by 5/6 works. So let me show you what that looks like. Divide by 5/6, divide by 5/6, and I'm like, oh, those have to cancel out because anything divided by itself is just 1. That's x. Now, the problem is I don't know what 5 divided by 5/6 is. But at some point in time, my math teacher in probably 5th grade taught me that when I divide by a fraction, it is the same as multiplying by the reciprocal. So that is times 6/5. Those are identical statements. 5 divided by 5/6. Okay? And so there's 2 ways I can do this. I can say this is 5 over 1. So that is 30 over 5, or 30 divided by 5 is 6. Or if you notice, oh, I have 5s here. I have 1 5 in the top and 1 5 in the bottom. Some of you might know, oh, I can cancel those, and I still get the 6. But basically, anytime I multiply 2 fractions, if I have like 3 halves times 7/4, I multiply the 2 things in the top, and I multiply the 2 things in the bottom, and then I simplify if I can. But I also can cancel things out in the top and bottom if they're multiplied on the same side of the equal sign. So that was just a little review. Okay, and I hope you could have seen that. I might have been off the screen. Okay, so ignore that. Okay, so 5 divided by 5/6 is the same as 5 times 6 over 5. If you want to put that over 1, you can. And then you can say, oh, those cancel out. X is equal to 6, which I think was one of my choices. It was, and I could plug it back in. Actually, let me show you how that works if I plug it back in. 5/6 times 6 minus 7 equals negative 2. So this is our check. Okay, this is the same as 6 over 1. Once again, 30 over 6 is 5, or I can just cancel it out and get 5 minus 7 equals negative 2. And then once again, 5 minus 7, or I can think of this as 5 plus negative 7. I subtract the 2, but keep the sign of the bigger one, which is the negative 2. Negative 2 is equal to negative 2. That all works out. Okay, last one. I'm going to pick one that's hard. No, I'm not. I'm going to pick one. I'm not going to do another fraction one. No, I'm going to make up a fraction one real quick. Yeah, let's do this. Negative 1/5 x minus 3 equals negative 5. Real quick. Plus 3 equals, that's a negative 2. This is a negative 1/5 x. The reason I'm redoing this is I want to show you, instead of dividing by negative 1/5, if I wanted to, I could just go ahead and multiply by the reciprocal. That is the same step. Multiplying by the reciprocal is the same as dividing by 1/5. Okay? Negative times a negative is a positive. That all cancels out to 1. Negative times a negative is a positive. That's a positive 10. And if I plug that back in, negative 1/5 times 10 is a negative 2 minus 3. Okay, that all checks. All right, I'm going a little long here. This is my last one. I'm going to show you a distribution problem. And you got two choices here. So the answer I've got here is, that one looks too hard. Where's one that looks a little easier? Yeah, we'll just do that one. 14 times x plus 4 equals negative 196. I have two choices here. I can either distribute these two first, if I want to, and get 14x plus, can I do that in my head? I think that's 56 equals negative 196. In fact, that's what I'm going to do. 14x plus 56 equals negative 196. I'm going to minus 56 from both sides. I'm going to do so I get 14x equals 140. Oh, that actually, I thought that I was going to have to drag the calculator out. That I can do in my head. 14x divided by 14, x equals 10. And then I can go back and check it. Your other choice here, if you had wanted to, and then I'm done. I could have divided by 14 first. I would have gotten x plus 4 equals negative something. Oh, that seems like that's not going to work. Oh, it must be negative 14. But then what happened over here? Oh, I dropped a sign. Mistake. I'm going to cut this out. There's a mistake in here. This doesn't actually check, and I will cut it from the video probably.